Okay, so let's graph this, and I'm going to make sure that my x values have some space on the negative x-axis, since my x values for my transform function are all negative. And that makes sense because the graph was shifted to the left 3, so all my x values are making sense. In terms of my y values, I'm going to make sure that I have some negative y values and some positive y values as well, because I have a positive value for y here, and I also have a positive horizontal asymptote. So let's sketch our graph. We're going to do something like this. Okay, so here's our x-axis, here's our y-axis. And x needs to go up to -4 at least. So -2, -4. Y values, I need to make sure it goes at least up to 2. And 1, 2, 3, 4, 5. So -2, -4. And the first thing I'm going to graph is my horizontal asymptote, because that's going to create a barrier for my graph. So I have a horizontal asymptote at y equals 2. And then I can plot my points. So -4, -4 is the first point. And -3 and -1 is the second point. And -2 and 0.5 is the third point. Now again, one of your points will be close to the asymptote, the other one will be far away. And you'll notice that the one that's far away indicates that the graph is going to continue towards -infinity in that direction. But the graph is going to approach the asymptote from the point that's already close to the asymptote as it is. Okay, so there's the sketch of the graph that we have for the exponential function. Remember, one end has to approach the asymptote, the other end approaches either -infinity or +infinity, depending on which direction it's moving. So this is a graph of y equals -3 times 1/2 x plus 3 plus 2. Okay. Looking at the domain. Again, the domain for this is all real numbers, because the graph can continue to the left and to the right indefinitely. The range here is values of y such that they are lower than 2. Because your asymptote is at 2 and your entire graph is below the asymptote, we know that y has to be less than 2, and y is an element of all real numbers. And the equation of the asymptote, like we talked about earlier, is y equals 2, and that's based on the fact that the graph is shifted up 2 units. Okay, is the function increasing or decreasing? Now, this is kind of weird. Normally, when we have a function where the base is less than 1, we're expecting the graph to be decreasing. So it should sort of look like this. But now this is weird. If I look at the graph from left to right, I notice that the graph is actually getting higher and higher and higher, which means that the graph is actually increasing. Now, why did that happen? Well, if you have a decreasing graph and you reflect it along the x-axis, then what ends up happening is you now have an increasing graph. Okay? So we went from a decreasing graph down to an increasing graph because of a reflection along the x-axis. So because of this horizontal reflection, now the graph is actually increasing instead of decreasing. So, in conclusion, what I want you to notice is that horizontal or vertical reflections can actually change some of the behaviors of an exponential function. And the behavior in particular that a reflection changes is whether the function is increasing or decreasing. So here we saw that a vertical reflection in the x-axis changed a decreasing graph into an increasing graph.